Hi everyone. Today we are discussing the topic is parallelism. So parallelism is a multiple processor can execute the multiple instructions. That is parallelism. The processing data concurrently is known as parallel processing. So in parallel processing method can be implemented with the help of multiprocessor. So what is the meaning of multiprocessor? We are having a n processor. So if any one processor can fail, the system would continue the process into the another processor. For example, if your system having a n processor, in this processor any one processor can fail, automatically the number of processor can be reduced by 1. So next time the instruction can be executed with the help of n minus 1 processor. So parallelism mode of operation can split the whole instruction or whole program into subparts. So each and every subparts can be executed in different processor. And finally it will be combined, we can get the single output. So whenever we can insert the program or whenever we can execute the program in a single representation, and then we can continue the process with the help of your multiprocessor systems. So multiprocessor system can execute the processor one by one. For example, if you are having a one processor, so we can execute the whole instruction with the help of only one processor. If you are having a multiprocessor, at the time we can execute the program. We can execute the single program. In the single program can be split into n number of subprograms, so that n number of subprograms can be execute only one process, n processor. So this is called a parallelism method. So in this parallelism method, we are having a two ways. One is multiple functional unit that having a more than one ALUs, and multiprocessor we are having a two or more processors. So in this multiprocessor system, we can take task level parallelism or process level parallelism. So what is the meaning of task level parallelism? Each and every program or each and every problem statement will be converted into task representation. So for example, if you are how to create a web page, so in this representation, how to create a web page, we can give admin username, password. Likewise, each and every time we can conclude the content with the help of your representation. So in this parallel processing, we are having each and every task and each and every process can be executed in the parallel mode. So after completing the each and every single task will be combined into cluster representation. So first of all, the multiprocessing system can be executed different types of tasks, and finally it will be clustered into a single representation. So next one, multi-core. So what is the meaning of multi-core? It is an architectural design for multiple processors in a single representation. So it may be a multiple chip can be combined in the one integrated circuit. We can create a multiprocessor. So for example, dual, prod, hexa, octa. So like type of various types of multi-core available in the computer system. So why the multiprocessor is necessity? So first one, it reduces the power consumption, and second one, it will be having a low cost. That is, it will be reduced the cost will be cut. So that is a representation of, that is a necessity of your multiprocessor. The next one is goals of parallelism. So what is a goal? Why we are using a parallelism? So the computational speed can be increased with the help of your parallelism. And second one, if you are using two or more ALUs in a single CPU, can work concurrently means the throughput will be increased. So what is the meaning of throughput? Each and every time the service provided for a particular processor, that will be increased. So amount of processing can be accomplished during the given time of interval. So that is a representation of your throughput. And the next one, improve the performance of the computer for a given clock speed. So it will be improve the clock speed of your representation. So next one, types of parallelism. So what is in type? What are the types will be implemented with the help of parallelism? One is instruction level parallelism. Second one, thread level, that is task level parallelism, bit level parallelism, data level parallelism, and transaction level parallelism. So instruction level parallelism. So first of all, the parallelism, we are splitting the processor. We are splitting the process, and each and every splitted process will be allocated to a particular processor. So first instruction level parallelism, we are having a processor we are having a set of instructions. So the instruction will be splitted and each and every instructions will be allocated towards a particular processor to execute. So next one, thread level. So that is the task, the process can be splitted with the help of task. So each and every task, for example, if you are having a more than 100 pages of program, we can have a sub function for executing a single program. In C language, we are using a subgroup function. Instead of we are having a whole program under the main function, we are having a n number of sub functions. So in this n number of sub functions will be represented as task. The same thing. So the instructions will be classified or it will be combined in a single task. That single task will be allocated to the processor. That is representation of thread level or task level parallelism. So next one, bit level parallelism. So we are representing the zeros and ones representation. That bit level parallelism will be allocated to the processor. Data level, based on the data, we are allocating the task or we are allocating the instruction to the processor. That is data level parallelism. So transaction level parallelism, communication between the register or between the data memory and how the data will be transferred, like type of process will be communicated with the help of your transaction level parallelism. So first instruction level parallelism. So we are having so many sequence of instruction that may be independent. At the time we can execute the instruction in the parallel with the help of your instruction level parallelism. So what are the two primary methods in the instruction level parallelism? One is increasing the depth of the pipeline and replicating the internal components. So what is the meaning of increasing the depth of the pipeline? So first of all, what is a pipeline? The pipeline, we are having so many instructions. So one instruction output can be inserted into a next instruction input. So that is pipeline. So in this representation, the depth of the pipeline can be increased with the help of your instruction level parallelism. Second one, replicating the internal components. So the internal component can be replicated with the help of your instruction level parallelism. And also we are having so many features by using your instruction level parallelism. One is implementing multiple issue processor, that is, it may be a static or it may be a dynamic. Speculation, it will be used for identifying the properties of instruction. And the third one is recovery mechanism, that is exception handling, will be implemented in the instruction level parallelism. So if you are identifying any drawback or if you are identifying any problem, automatically you can provide the solution for a particular problem, that is recovery mechanism handled by the exception handling. The next one, instruction issue policy. So the instruction issue policy can be used for in-order issue or with the help of in-order completion, and in-order issue without having a out-of-order completion, the out-of-issue having a outer order completion. So this is completion range of your instruction level parallelism. And register naming. So if you're having more than register we are using, at the time we can, if you're having any confusion, you can rename the register with the help of your instruction level parallelism. And branch prediction. So how the branch will be identified, automatically we can use the adder to conclude the next instruction with the help of your branch prediction. So next one, parallel processing, the challenges. So what are the challenges we can face? It may be a hardware and software. We can't easily find out which one is the correct representation for the parallel processing, and the efficiency of the performance and energy can be executed with the help of your parallel processing program. And the next one, challenges. So writing the program is not easy for representing a parallel processing, and scheduling is a main problem while using a parallel processing. And partitioning the task is also not possible. So first of all, we can allocate the task to the processor. Before allocating, we can splitting the task. So the partitioning is not an easy thing. How we can partition the task is not identified easily. And the next one, balance the load between the processor is also one of the challenges for your parallel processing. So by using the parallel processing, that Amdahl's law will identify the performance gain by using your parallel processing challenges. So this is a formula for identifying your parallel processing challenges. So fly-in classification to avoid the, to improve the challenges in the parallel processing, we can use the two basic steps. One is parallelism in the instruction stream and parallelism in data stream. Instead of task, thread, all those things we can implement it. before, I mean, after these challenges, we can identify the Flynn classification only using the two types of parallelism representation. One is instruction level, another one is data level. In this, we are having a four possible combinations. So what are this? We can see single instruction, single data. So only one execution. I mean, only one instruction can be executed in the processor with the help of only one data at a time. The next one is a single instruction, multiple data. The instruction can use a multiple data, means we can allocate the processor execution. So this is a control unit. So this control unit will control all the process execution. We can have a more than data. So each and every time we can allocate the data to the particular processor execution that not affect any parallel processing. So automatically we can give the data and we can retrieve the data to the memory. So next one, multiple instruction in single data, it's having some problem to arise because we can use the same data in the different location. Means if you are updating any data in the representation, automatically it will be affecting the result of the next processor. And the next one is multiple instruction and multiple data. So most of the multiprocessor system having a multiple computer system come under this category. So multiple SISD, so that is each and every data will be allocated to each and every process. So that's not having any major challenges in this location. So this is a parallel processing. Thank you.